Molar mass is a mass in grams for 1 mole of a substance. So now we're going to bring in the concept of mass and tie it to the 6.022 times 10 to the 23rd. So 1 mole of copper, not only do we know it equals 6.022 times 10 to the 23rd atoms, but a chemist knows that a mole of copper is 63.55 grams. Now I'm going to ask you to pause the video for just a minute and see if you can figure out why a mole of copper is equal to 63.55 grams, because that's unique to copper. Water is going to have a different molar mass or a different mass in grams for 1 mole of water. Okay, maybe some of you can already see why copper is 63.55 grams. I'm going to give you another example before I lay it out and let everybody see exactly where this value comes from. Let's look at a mole of carbon, and a mole of carbon equals 6.022 times 10 to the 23rd atoms of carbon. But instead of it being 63.55 grams like copper, a mole of carbon is actually 12.01 grams. So the mass of a mole of carbon is different from the mass of 1 mole of copper. They both are 6.022 times 10 to the 23rd atoms, but you can see that a mole of copper is much heavier. Pause the video again and see if you can see the pattern now, if you couldn't see it the first time. Okay, those of you that see the pattern, this will come as no surprise to you that a mole of iron, knowing it equals 6.022 times 10 to the 23rd atoms of iron, is also equal to 55.85 grams of iron in a mole, because this value is from the periodic table. It's the average atomic mass of all of the different naturally occurring isotopes of iron. So if you didn't already pull out your periodic table, let's take a look at it and notice that copper's average atomic mass is 63.55 grams. Carbon's average atomic mass is 12.01 grams, and iron's is 55.85 grams. So we get molar masses for elements straight off the periodic table. Now when we talk about compounds, or we talk about molecules, formula units, we have to take a little bit more into consideration. So let's take a look now at getting the molar mass of a molecule. And let's go back to the concept of water. 1 mole of water is equal to 6.022 times 10 to the 23rd molecules of water, but that equals 18.02 grams for a mole. Well, where does that come from? That isn't a value straight off the periodic table. Well, we have to keep in mind that water is actually 2 atoms of hydrogen and 1 atom of water. And so when we do the molar mass of water, we have to take 2 of hydrogen's molar masses, so that would be 2 times 1.008, plus we have to add the mass of 1 oxygen, which is 16.00. When we add that together, actually I'll bring the math out here, you have 2.016, and this equals 16.00, way back to the beginning of the year when we talked about adding and keeping track of significant figures. Because the 16.00 ends 2 to the right of the decimal, it's less accurately measured than the value for hydrogen's molar mass. So although your calculator would tell you it's in fact 18.016 grams, we would round and say water's molar mass is 18.02 grams per mole. And notice that the label for molar mass is grams per mole, telling you that there are 18.02 grams of water in 1 mole of water. There are 18.02 grams of water is equal to 1 mole of water. We're going to look at some other compounds, and then I'm going to give you a chance to practice. Let's look at the molar mass of a compound like dinitrogen tetroxide. Now, when you look at dinitrogen tetroxide, you see that it's a covalent compound, again, formed by those sharing of electrons. Because it's got prefixes, we don't need a T-chart. So what we're going to do is write the chemical formula. Dinitrogen means you have 2 nitrogens. Tetroxide means you have 4 oxygens. If we want to do the molar mass of dinitrogen tetroxide, it would take 2 of the hydrogens plus 4 of your oxygens. And when we add this together, we're going to get 28.02, and then we're going to get 64. And carrying down the values, if I did my math correctly, and please excuse me if I don't, you would get 92.02 grams in 1 mole of dinitrogen tetroxide. That's how you figure out the molar mass of a covalent compound. You'll have plenty of time to practice with your practice sheet. I just want to run you through a couple of examples here. We're going to finish my video with a calculation of the molar mass of an ionic compound. So when you look at an ionic compound, let's take something like calcium nitrate. It's going to give us the chance to practice making a T-chart. Because it's an ionic compound, notice no prefixes, and you recognize those ions from the table. Calcium is a +2 charge. Nitrate is a -1 charge. You have 1 calcium for every 2 nitrates. And when we write the chemical formula, we would write it as CaNO3 And now when it comes time to do the molar mass for calcium nitrate, you're going to have to look really closely at the chemical formula. You can see you have 1 times the molar mass of calcium, which is 40.08. You have 2 of the nitrogens because you have 2 nitrates, so it's going to be 2 times 14.01. Plus you're going to add, now notice, you have 2 nitrates. That gives you 6 of the oxygens. So it's going to be 6 times the molar mass of oxygen. Well, you've got, let's see, 6 times 16 would give you, doing the math here, I think 94, but let me just double check it. 6 times 16 equals, oh, it's 96. Good thing I checked. So we've got 96 plus 28.02 plus 40.08. I got sloppy with my significant figures. Let me go back there. So what you're going to get when you add this together for molar mass is 40.08 plus 28.02 plus 96 equals, oh, that didn't work right. Let me just add it up here. I'm having calculator issues. 114.7. Hopefully 164.10. Again, please excuse me if my math is wrong. You are chemistry students. You'll certainly be able to figure out the math here. I foolishly did not bring my calculator with me when I set up my recording here. But if I did my math correctly, you can see that there are 164.10 grams per mole. You're going to get a practice sheet now that gives you the opportunity to practice molar mass, and I would strongly encourage you to do so. We're going to have a quiz using molar mass later in the week, and every calculation we do from now until the end of the year that involves stoichiometry will involve you using molar mass. Thank you for listening, and have a good day.